Hello everyone, welcome to my presentation. I am Sangeeta from Sri Venkateswara College of Engineering from the Department of Computer Science and Engineering. Today we are going to discuss about the topic computer networks. Computer networks are social networks. It is one of the research paper which was published where computer networks is used as social networks. In this presentation, let us briefly understand how the computer networks is used as social networks. This presentation explores the connection between computer networks and social networks, drawing parallels between their structures and dynamics. We examine how the principles of social network analysis can be applied to understand and optimize computer networks. The presentation will dive into the theoretical foundation of network theory, demonstrate the similarities between these two domains, and discuss the practical implication of this research. Abstract. Exploring network similarities. This research examines the parallels between computer networks and social networks, highlighting their shared structural and dynamic characteristics. Applying social network analysis. It explores how social network analysis methodologies can be applied to understand and optimize computer networks. Practical implication. The paper delves into the practical implications of applying social network principles to enhance computer networks design and performance. Introduction about computer networks and social networks. Computer networks. Computer networks are interconnected systems of devices that communicate and share information using protocols and infrastructure. They enable data transfer, resource sharing, and collaborative work, forming the backbone of modern digital communication and services. Social networks. Social networks are complex systems of individuals or organizations interconnected through social relationships. They facilitate communication, collaboration, information sharing, and influence within communities, shaping social dynamics and cultural trends. Intersection of networks. This research explores the intriguing connection between computer networks and social networks, highlighting their shared structural and dynamic characteristics. By drawing parallels between these seemingly distinct realms, we aim to unlock insights that can be applied to optimize both domains. Network theory foundations, nodes and edges, centrality measures, network density, and clustering. Networks are comprised of nodes presenting individual entities like computers or people and edges signifying connections or relationship between them. Nodes can be computers, routers, or even individuals in a social network, while edges present the link between these entities, such as physical connections or social interaction. Centrality measures. Centrality measures quantify the importance or influence of nodes within a network. Degree centrality, for example, reflects the number of connections a node has, while betweenness centrality measures the number of shortest path that passes through a node. Network density and clustering. Network density refers to the proportion of actual connections compared to the total possible connections in a network. Clustering coefficient measures the likelihood that two nodes connected to a third node are also directly connected to each other, revealing the interconnectedness of neighborhoods within a network. From computer networks to social networks. How the computer networks is evolved to social networks. Computer networks. Computer networks like the internet are built on physical infrastructure and protocols, enabling communication and data exchange between devices. These networks are designed for efficient data transmission, scalability, and reliability, emphasizing technical aspects. Social networks, in contrast, are built on social interaction and relationship between individuals or organizations. These networks are driven by social dynamics, influence, and information sharing, focusing on human connection and communication. Shared characteristics. Despite their distinct origins, computer networks and social networks share fundamental structural similarities. Both are composed of nodes representing entities connected by edges representing relationships. Both exhibit pattern like centrality, clustering, and network density, which influence their behavior and performance. Modeling computer networks as social networks. The first thing is basic graph model. So in the basic graph model, we can model the computer networks as social networks. Treats devices as nodes and connections as edges, focusing on simple connectivity. This model is useful for initial analysis but lacks context about node attributes and interactions. The second model is attribute based model, incorporates device attributes like processing power, bandwidth, and latency into node properties, providing more context for analyzing network behavior. And the third model is dynamic interaction model, captures the dynamic nature of network interaction, considering factors like communication patterns, data flow, and resource allocation over time. And the fourth model is community based model, identifies groups of nodes with similar characteristics and interactions, revealing community structures within the network similar to social circles. Insights from social network analysis. Centrality and network importance. Social network analysis reveals that certain nodes are more central and influential than others. In computer networks, this insight can be used to identify critical devices like routers and servers that are essential for overall network performance. Community detection for resource allocation. Social network analysis helps identify communities or groups of nodes with similar characteristics. In computer networks, these communities can represent groups of devices with specific functionalities or requirements. By understanding these communities, network resources can be allocated more effectively, ensuring that the devices with similar needs receive the appropriate bandwidth and processing power. Influence and information flow. Social network analysis helps understand how information spreads and influences others within a work. This knowledge can be applied to computer networks to optimize data routing and information dissemination. By understanding the pathways of information flow, network device designers can ensure efficient data delivery and prevent bottlenecks that hinder network performance. Implication of computer network designs. The first one is resource allocation, and the second one is traffic routing, security and resilience, and the last one is network evaluation. Social network analysis helps identify communities with similar characteristics. This helps optimize resource allocation. Traffic routing is understanding how information spreads in a network. A key concept in social network analysis can be applied to optimize data routing. This helps ensure efficient data delivery and reduces bottlenecks. Next one is security and resilience. By analyzing the connection and relationship between the nodes, network security can be strengthened. This includes identifying critical nodes and implementing targeted security measures to protect them. Network evaluation. Social network analysis provides insights into how networks evolve over time. This can be used to predict network growth and adapt network design for future needs. Challenges and limitations, data collection and accuracy, dynamic network behavior, complexity of interactions, privacy concerns. These are the challenges and limitations of using computer networks as social networks. So the gathering accurate and comprehensive data on device attributes may be a challenge. And the computer networks are dynamic systems with constantly changing connections and traffic patterns. The interactions between devices within a network are often complex, involving multiple protocols, routing mechanism, and security protocols. Traditional social networks analysis method may not fully account for these intricacies. Privacy concerns is applying social network analysis to computer networks raises privacy concerns. There will be no privacy for the data which are transmitted from the computer networks devices where we use as social networks. So this may be one of the challenges of using computer networks as social networks. Future directions. What are the future directions that can be used the computer networks as social networks? The first one is advanced network modeling, real-time analysis, hybrid network architectures, and ethical consideration. These are the future directions of using computer networks as social networks. Thank you.